For today's video, we're gonna have a review on the Coulomb's law using our Phet simulation. So this is actually our Phet simulation for understanding Coulomb's law. Now, when we're talking about electric force, we talked about the two sets of conditions, right? The first condition on the strength of the electric force depends on the magnitude of the charge. Diba? So it was said that the greater the amount of charge, the greater is the force. Now our second condition is the strength of the electric force depends on the distance between charges. Now it says there that the greater the distance, the lesser is the force. Now I want you to see in my screen, I have here a Phet simulation now of on the electric forces of atoms. Now we have here our quarks 1. Our quarks 1 is actually negatively charged, while our quarks 2 is positively charged. Now, knowing that they are of opposite charges, what do you think is most likely the electric force between the two? Would it be attraction or repulsion? Now, look at the arrow above quarks 1 and above quarks 2. The arrows are moving or pointing towards each other, meaning that opposite charges attract. And so that's why you can observe that the arrows are attracted or are pointing towards one another. Now, I want you to look at the arrow on quarks 1. This arrow is actually a depiction on the force exerted by quarks 2 on quarks 1. While the other arrow, quarks 2 arrow, the arrow that you can find above quarks 2, is actually the force exerted by quarks 1 on quarks 2. Now this time, what do you think will happen if I try to move quarks 1 closer to quarks 2? I want you to observe the values above the force on Q1 by Q2 and the force on Q2 by Q1. Kindly observe what happens if I try to move quarks 1 closer to quarks 2. As you can see, the values are increasing as I try to lessen the distance between the two. What another observation do you see? The force on quarks 1 by quarks 2 is equal to the force on quarks 2 by quarks 1. Why? Because it follows the Newton's third law of motion, the law of action-reaction. It says there, when there is, in every action, there is always an equal but opposite reaction. So as you can see, they are both equal, but the direction of the arrows are actually opposite of one another. Now let's try if both charges are negative. What happened to the arrow? The arrows are pointing away in opposite direction as well. They are pointing away from each other because the electric force observed is repulsion. But you can still notice that despite that, the forces exerted on Q1 and on Q2 are the same. Still, because of the Newton's third law of motion. Now, you really have to understand this Phet simulation and Coulomb's law before we try to solve some problems on Coulomb's law.